Algebra 1, Unit 5C, Test Review, Problem 16, the last problem. Mr. McDonald's physics class investigates what happens when a ball is given an initial push, rolls up, and then back down an inclined plane. An inclined plane is something like a slant board, or the ramp for a skateboarder to take off, or even a wheelchair ramp. The class finds that y equals negative x squared plus 6x accurately predicts the ball's position after rolling for so many seconds. Sketch the graph. Make sure you label your axes. X is time. They tell me that x is my number of seconds, so that is time. The position is the number of feet away from the bottom of the inclined plane. If x equals 0, y equals 0. If x equals 1, y equals 5. I can solve this easily by hand if I do not happen to have a calculator handy. After all, negative x squared, 2 squared is 4, negative 4 plus 6x, 6 times 2 is 12. 12 minus 4 gives me 8, and so forth. I can calculate all of these easily. Here is my graph based on the points: 1, 5, 2, 8, 3, 9, 4, 8, 5, 5, 6, 0. You'll notice that I used every hash mark is half a foot because I wanted to use a lot of space. I did not connect my dots because I don't draw pretty curves. Determine a reasonable domain and range for the problem situation. The domain is all possible values of x. The time begins at 0, so the time could start at 0. The time could go on forever, but for this problem, the ball comes back down and goes to rest at 6 seconds. So a reasonable domain is x is between 0 and 6 seconds. The range for my problem situation: the ball begins at 0, it goes out, it comes back. The farthest away it goes from my starting point is 9 feet. The range is all possible values of y. So it is 0, y is between 0 and 9 feet. Now this is a continuous function. It's not a stepwise function. So I really do need to complete the curve to the best of my ability. It may not be beautiful, but I need to show that I understand that this is a continuous function. The ball can't travel like Mr. Spock does and be here and skip time and space and then materialize over here. That's not what happens in our world. What are the solutions to the quadratic function graphed? X equals 0 and x equals 6. What do the solutions mean in this problem? Well, the solutions represent the moment just before the ball is pushed up and the moment at which the ball stops again at the bottom of the incline. We have worked hard. We have studied a lot of mathematics, and we look forward to doing a really good job on the test on Monday. Please notice I did not solve 11 and 12 for two reasons. First of all, you need to practice these skills on your own. And second of all, we have done so many other problems using graphing and factoring and tables of data that I believe you should be able to do these on your own. However, if you have listened for this long, here's my solution to 11. And here's my solution to 12. Good luck on Monday. I am going to dinner with my daughter and her family. And I hope you have something fun planned too. Bye-bye.